limiting reagents and percent yield. Let's say we have this balanced chemical equation, and what would happen if we had 3 moles of N2 react with 3 moles of H2, according to that balanced chemical equation. Well, in the chemical equation, it's 1 mole of N2 for every 3 moles of H2. So what's going to happen is if we have 3 moles of each, the H2 is going to get used up completely, and there will be some extra nitrogen left. There will actually be 2 moles of N2 left over, and that will be in excess. So the hydrogen is called the limiting reagent. The reaction stops once the limiting reagent is used up. So once the hydrogen is used up, the reaction stops. Nitrogen is the excess reagent. So even though it's there in excess, the reaction cannot continue because there's no hydrogen left over. So now we're going to do some calculations with limiting and excess reagents. Let's say we have 1.75 moles of H3PO4 and we have 5 moles of NaOH. And I want to know what the limiting reagent is. Since I have 2 numbers, the easiest way to set these problems up is to set up 2 separate equations. So I'll start with 1.75 moles of H3PO4 as my first equation. It does not matter what product I solve for. So I will solve for the Na3PO4. There's 1 mole of H3PO4 for every 1 mole of Na3PO4. So 1.75 moles of H3PO4 would produce 1.75 moles of the product, sodium phosphate. And we're going to start with the 5 moles and do a very similar calculation. 5 moles of NaOH. We're going to solve for the same product. We're going to do the mole-to-mole ratio. In this case, it's 3 moles of NaOH for every 1 mole of Na3PO4. So 5 moles of NaOH would produce 1.67 moles of Na3PO4. Now the question is, what is the limiting reagent? The limiting reagent is the reactant that gets used up. Well, the limiting reagent is always the one that produces the smallest amount of product, which in this case was the 1.67 moles of Na3PO4. So my limiting reagent, the reactant that gets used up completely, is NaOH. So once that gets used up, the reaction stops. Okay, so let's look at another example. We have 2.7 moles of C2H4 reacting with 6.3 moles of oxygen. Identify the limiting reagent. Very similar type of problem. Since we have 2 numbers on the reactant side, I'm going to set up 2 separate equations. And again, it does not matter what product I solve for, as long as you solve for the same product. And so I will solve for the water in this case. We're already in moles, do a mole-to-mole ratio. So in the top equation, 2.7 moles of C2H4 would produce 5.4 moles of water. In the bottom, when I'm starting with 6.3 moles of oxygen, my mole-to-mole ratio here is 2 moles of water for every 3 moles of O2. So 6.3 moles of oxygen would produce 4.2 moles of water. So it doesn't matter which product we solve for as long as I solve for the same product. My limiting reagent is the one that produces the least amount of product. So my limiting reagent is oxygen that will get used up completely in this reaction. Now there's a second part to this problem, and I changed it up on your notes. So instead of the question it asked on your notes, you can write this in: how much excess reagent remains? In other words, there's going to be a reactant that's left over. How much is left over for that reactant? Well, I know, I'm basing on the previous problem, my limiting reagent is oxygen. So I want to start there. I want to start with my limiting reagent, and I had 6.3 moles of oxygen. So I will start with my limiting. You always start with your limiting reagent. What I want to do is go back to my other reactant, because I know that was in excess, and that was C2H4. So I'm going to do the mole-to-mole ratio, go back to C2H4, because I know the C2H4 was in excess. Okay, so if I start with 6.3 moles of O2, that means I need 2.1 moles of C2H4. This is how much C2H4 will react. It's not how much is in excess, that's how much reacts. If I want to get the excess, I simply take what I started with for the C2H4, which if you go back to the problem, you started with 2.7 moles, only 2.1 reacted, so that leaves an excess of 0.6 moles. So that's how I get my excess reagent. Okay, let's go on to another problem with limiting reagent. We're starting with 6 grams of HCl and 5 grams of magnesium. The only difference between this problem and the previous ones is they're starting in grams and not moles. We're still going to set up two separate problems. So we will start with 6 grams of HCl, and we will start with 5 grams of magnesium. Now there's a two-part problem here. Identify the limiting reagent, but also how many grams of hydrogen will be produced. So what I want to do is solve for the mass of hydrogen. Like I said, it doesn't matter which product you solve for, but since I'm looking for hydrogen in the problem, I might as well solve for that. So we'll start with the 6 grams of HCl first. Since we're in grams, we need to go back to moles. So we need the molar mass of HCl, which is 36.5 grams per mole. Now we do the mole-to-mole ratio and go back to the balanced chemical equation. There are 2 moles of HCl, and I want to go to hydrogen for every 1 mole of hydrogen, if you look at the coefficients. And I want to add one more step because I want to know the grams of hydrogen that will be produced. So we're going to go from moles back to grams. H2 has 2 grams per mole. So if you solve this one, you get a mass of hydrogen 0.164 grams. With the 5 grams of magnesium, we're in grams. We need to go back to moles. Molar mass, 24.3 grams per mole from the periodic table. Now we are in moles, so we're going to do the mole-to-mole ratio. There's 1 mole of magnesium. We're going to go to hydrogen, same product, 1 mole of H2. Last step is exactly the same because we want to go to grams of hydrogen, so 2 grams per mole. So if I have 5 grams of magnesium, that will produce 0.412 grams of hydrogen. Now let's look at the questions. Identify the limiting reagent. Limiting reagent is the one that is used up. Well, my limiting reagent is HCl. That produces the least amount of product. Second part, how many grams of hydrogen will be produced? I've already answered that as well. It's always the smallest number. So how many grams of hydrogen? 0.164. There's excess magnesium, so that number, the 0.412, is irrelevant in this case.